So our project is testing speed differences between juvenile and adult Madagascar hissing cockroaches. My name is Sean.
I'm Taylor.
I'm Amin.
I'm Aman.
I'm Shariful.
Madagascar hissing cockroaches are found on the African island of Madagascar and are found nowhere else in the world. They live in the forest floor eating detritus such as fallen fruit and dead leaves. They have 6 instars, or juvenile stages, before becoming an adult. Tateshi et al. In 2020 found neurological and behavioral differences between adults and juveniles, and Schaefer and Sanchez discovered differences in their antennae. Because they're sexually dimorphic, we've hypothesized that there will be a difference between the speeds of juvenile and adult Madagascar hissing cockroaches because the adults are physically, metabolically, and behaviorally different from juveniles.
So I'm going to be talking about the experimental design. First things first, let's go over the materials. So we needed some pretty simple materials, a timer, which we just used a phone. In this case, we didn't use a maze, we actually used 2 tracks. And then we need to randomly select an adult and a 4th level instar nymph cockroach. And so our design was also pretty easy too. We had 4 replications for our experimental variable. We had to make sure that they were the correct stages of MHC. So we had 1 adult and then, the nymph. And then our controlled variables were making sure that the tracks were the same length, make sure that there is the same environmental conditions, and then as I mentioned, just make sure we have a 4th level instar.
Now if we look at the results obtained from our long-term experiment, we can see that there is a difference between the speeds of adult and juvenile Madagascar hissing cockroaches. But is this difference significant enough? If we look at the table, we can see that the second fastest adult MHC that took around 15 seconds, and there is the slowest juvenile MHC which also took around 15 seconds to complete the track. Now we can say that there is some definite overlap in between the 2 data sets of adult and juvenile Madagascar hissing cockroaches. Now if you look at the averages, we can see that there is a difference between the speeds of adult and juvenile MHCs. But is this difference significant enough? Can we rely on the averages entirely? No, right? So we have to perform a statistical analysis to have more confidence in our dataset, and so that we can say that either this difference is significant enough or not significant enough.
We know speed equals to distance by time. In our case, distance is constant. That means the length of the track. So we are counting time as a measure of speed. We also know the relationship between time and speed is opposite. That means the longer the time is, the slower the speed is. In our graph at x-axis, we have our independent variable, the types of MHC, that means adult and juvenile, and at y-axis, we have our dependent variable, time. Time was calculated in seconds, and this red bar is indicating average time taken by adult MHC to complete the track, and the blue bar is indicating average time taken by juvenile MHC to complete the track. It is evident from the graph that on average juvenile MHC was faster than the adult MHC. But just looking at the graph, we can't conclude anything. To reach to a conclusion, we have to do statistical analysis.
To perform a t-test analysis, the first thing that we need to find out is the degrees of freedom. The degrees of freedom for our experiment is 6 because we had 4 replications for each of the treatments, that is adult and juvenile Madagascar hissing cockroaches. Now the t-table value at 6 degrees of freedom and at a significance level of 0.05 is 1.94, whereas the t-calculated value at 6 degrees of freedom is 1.83. Now the t-calculated value is less than t-table value. What does this suggest? This suggests that our data is not significant enough. There is not a significant difference between the speeds of adult and juvenile MHCs. And if we compare the p-values, the p-calculated value is 0.12. What does this mean? This means that we can only rely on our results for up to 88%, and there is a chance that our results are dependent on the randomness of the data for up to 12%. We can't leave things to random chance for up to such a bigger number, because as we know that in order to have significant results, we need to have a p-value of 0.05 or less.
The statistical analysis of our study doesn't support our hypothesis because the p-value was not significant. So how can we increase the significant level of our study? So one way is to increase the sample size. We started working with fewer sample size, only 4 replications. So if we increase the replications, then we can increase the p-value. And on the other hand, we can decrease the p-value of the data. In addition to that, we can increase more trials for each day. Speed differences are not are observed for some other species, but to the best of our knowledge, we don't have a study that discussed about the speed differences of Madagascar hitching cockroach. So if we have more information related to this experiment, then maybe we can design the experiment in better way. However, difference may exist in this study, but our experimental design does not support it. So what are the implications of this study? No other previous studies have identified working on the speed differences between juvenile stage and adult stages of Madagascar hissing cockroaches. So we started working with something new. In addition to that, this study may help us to understand the physiological or metabolic differences between juvenile and adult Madagascar hitching cockroaches. It may help us to use evolution in understanding the physiological differences of Madagascar hitching cockroach over time. These are the 2 papers we cited in our background information. So that's all about our presentation. Thank you everybody for listening.